Hello everyone, let's discuss a very important concept of organic chemistry. We have heard about the Grignard reagent, that is basically RNGX, and we know that Grignard reagent can act as a good nucleophile. Grignard reagent act as a strong base whenever acidic hydrogen is present, but we have never heard like it can act as a reducing agent or not. So the question is, can it act as a reducing agent? Okay. So in this lecture, we are going to discuss about the reducing nature of Grignard reagent when the GR can be acting as a reducing agent. Okay. One of the classic example that we have is in the case of diisopropyl ketone, that is diisopropyl ketone. If we just draw the structure of this is ketone, and we have isopropyl group. So this is diisopropyl ketone, and when it is treated with isopropyl, magnesium bromide, basically, when we are treating it with isopropyl magnesium bromide, so isopropyl is this one, magnesium bromide, MgBr. In that case, basically, when diisopropyl ketone is treated with isopropyl magnesium bromide, this Grignard reagent basically will be acting as a reducing agent. So let me explain the mechanism. First, why it will not be acting as a nucleophile. Suppose this is delta minus, delta plus. To act as a nucleophile, this carbon has to attack on this carbonyl carbon. But because of too much bulky nature of these two side group, that is isopropyl group, it is too bulky. And this, nucleophile is also having two methyl, bulky group. That's why this attack does not take place. Or basically, this Grignard reagent, that is isopropyl magnesium bromide, will not be acting as a, nucleophile in that case. So basically, here what will be the main function of that? Here it will be acting as a hydride donor. So let me explain how it will be giving the electron. So let's draw the structure separately. Okay. Let this group to be R. So we can write it as R and R. This R is basically isopropyl. And let me draw here the Grignard reagent, that is CHMe. And here it will be CH2H. And here it is MgBr. Okay. Now it will be donating the hydride. Okay. In this way, this magnesium and carbon bond will break down. It will shift to this place. Okay, because magnesium here it will be electron donor. Okay, and this hydrogen in the form of hydride will be attacking to this carbonyl carbon. Okay, and this will break this carbon oxygen bond. So after that, we'll get the intermediate, basically, that is the transition state here, basically transition state, and it will be a cyclic transition state. It will look like this. This bond will be breaking down, okay, and this new bond will be forming here. With the hydrogen, this bond will be breaking, and this double bond will be forming here. So you can see, and now this bond will be breaking, and MgBr, and once it get O negative, Mg and oxygen will have attraction. So this is very stable, you can say 6-membered transition state. Okay, 6-membered transition state. After that, it will result into final product, and the final product that will be getting is this one. Hydrogen will get attached and it will become O negative, MgBr positive, and this other will be simply propene, that is CH2 double bond CHNA. So basically, we are getting this after acidification or treatment with water, it will convert to RCrHOH. So basically, we are getting this as 2-degree alcohol, that is diisopropyl carbinol. This is diisopropyl carbinol, okay, as the final product. That is the reduced product, okay. And other byproduct that we have is propene, that is Me, CH double bond CH2. So this is one of the classic case in which the Grignard reagent is basically acting as a reducing agent. Okay, so that's all. Thank you.